The last section that we want to look at in terms of factoring is factoring completely. In order to be able to do this section, you need to be able to recognize the GCF for a polynomial and understand all the techniques for factoring polynomials that we've looked at so far. Our procedure, whenever we are talking about factoring polynomials in general: 1, factor out the GCF, and then 2, factor the remaining polynomial. Determine a technique that would work best, whether it be factor by grouping, factoring trinomials, or factoring a special product. Okay, so let's begin with a couple examples. Example A, we have 3x cubed minus 15x squared minus 42x. So the first thing that we want to look for is greatest common factor. So note that 3, 15, and 42 are all divisible by 3, which means that I can go ahead and factor that out. Also note that all of these terms have at least one x, so we can factor out an x. So I'm going to put that on the outside. Inside, I'm going to put the result of dividing by 3x. So 3x cubed, if we divide by 3x, we are left with x squared. Negative 15x squared divided by 3x is minus 5x. Negative 42x divided by 3x is minus 14. That's our first step. Now our second step is we want to factor what remains inside the parentheses. So we get x squared is x and x. Things that multiply to 14, 7 and 2 will work. And then we do have that they have to be opposite signs in order to multiply to negative 14. And we want our larger one to be negative, so we get negative 7 and positive 2. Now, one important thing when you factor completely is make sure that you bring down your 3x as well. And here is our final answer. If we move to example B, the first thing that I want to factor out is the common factor. All of these are divisible by 5, but not only do I want to factor out a 5, I want to factor out a negative, just to make it easier on myself when I start factoring the rest of it. So if we divide all of these by negative 5, we are left with x squared minus 10x plus 9. Bring down your negative 5. X squared factors to x and x. 9 factors to 3 and 3, but that will not get me to 10. And so we want to go with the other factors of 9, which is 1 and 9. Remember that we are multiplying to a positive 9, which means same signs. And we want to add to a negative 10, which means both need to be negative. And so now we are done with our factoring. Okay, so let's look at some that are just a little bit harder. So if we look at A, 24x cubed minus 20x squared y minus 24xy squared. We want to start with the common factors. So what is a number that goes into 24, 20, and 24? That's going to be 4. They also all have at least one x in common. And so now if we go ahead and divide each term by 4x, we are left with 6x squared minus 5xy minus 6y squared. Okay, we'll bring down our 4x. And then now we want to factor the rest of this. So in order to get to 5, I probably want to pick pretty small numbers. So I'm going to go with 2x and 3x for my firsts. For my lasts, we're probably also going to have to go with 2 and 3 again, only because if you go with 1 and 6, 6 cannot go in the first set because 2 and 6 have a common factor. Can't go in the second set because 3 and 6 also have a common factor, so we have to go with 2 and 3 again. But we want to put the 3 with the 2. We want to put the 2 with the 3, because again, remember, common factors cannot be in the same set. And now we want to figure out our signs. So we know that they are different in order to multiply to negative 6y squared. I want my larger quantity to be negative in order to get to negative 5. So I'm going to make my negative 3y, which is paired with the 3x, larger than my 2's, which multiply to 4. And we're done. If we look at example B, we have 8x squared y plus 34xy minus 84y. The largest thing that can be factored out is a 2 for our numbers. We can also factor out a y. That leaves me with 4x squared plus 17x minus 42 . Okay, so now if we go ahead and factor the last part of this, for 4x squared, I don't want to go with 2 and 2 because remember rule 2 for our factoring said that if your middle number is odd, then you don't want to go with 2 even numbers. So I'm going to go with 4x and x. 42, what are things that multiply to 42? Well, we have 1 and 42, 2 and 21, 3 and 14, 6 and 7. And so now which one of these is going to be our best bet? Well, in order to subtract a 42, I think that we want to go with the 6 and the 7. I'm going to put the 6 in the second set because it can't go with the 4, and 7 in the first set. So if we do this, we do get 24 and 7. That does give me 17 when we subtract. So now if we put in our signs, we know that they are different. I want my larger quantity to be positive, so my 24 I want to be positive. My 7 is negative. And if you do 24 minus 7, you do get 17. And so this is the correct factoring. Okay, last set of examples, same thing. We want to start by factoring out the greatest common factor, so let's start with example A, 12x cubed minus 3x. So our greatest common factor is 3x. If we factor that out, we are left with 4x squared minus 1. Note now that the inside thing is a difference of squares. So we'll bring down our 3x. 4x squared breaks down to 2x and 2x. 1 breaks down to 1 and 1. Difference of squares, they will have different signs. So our final answer is 3x times 2x minus 1 times 2x plus 1. Let's look at a couple more. B. First thing we want to do is factor out a 5. So if we factor out a 5, we are left with 16 minus 25x squared. Bring down our 5. 16 factors, 2, 4, and 4. 25x squared factors to 5x and 5x. And again, since we are talking difference of squares, we do have different signs. So our final answer is 5 times 4 minus 5x times 4 plus 5x. Now, example C, we have x to the 4th minus 81. There is no greatest common factor here, but there is still a reason this is in this section. So let's go ahead and factor difference of squares. X to the 4th breaks down to x squared and x squared. 81 breaks down to 9 and 9. And we have different signs. Now, we're not done, because though we can't factor x squared plus 9, we've never talked about sum of squares, and the reason we haven't is because it doesn't factor any further. But x squared minus 9 is, again, difference of squares, so we can factor that one down even more. So first I'm going to bring down the thing that doesn't factor any further. And then now we have x squared is x and x. 9 is 3 and 3. And again, we have different signs. So that is how this factors. Make sure that you're very careful that sometimes it may not be a greatest common factor, but it does continue factoring more than one level. So that takes care of all of our examples for factor completely. In general, when we talk about factoring, we do have some guidelines. So, our procedure for factoring is 1. Factor out the greatest common factor if possible. 2. Look at the number of terms in the polynomial. If there are 4 terms, try factor by grouping. If there are only 2 terms, determine if it is a difference of squares or sum or difference of cubes. If there are 3 terms, try using some of the general strategies that we discussed in the previous sections. Check to see if you can factor anything further, like that last example we saw in terms of the difference of squares that contain difference of squares. You should check your answer by multiplying the factors together and making sure that you come back to the original problem. Note, if you cannot factor anything, then it is a prime polynomial.